Welcome. So in this lesson, we're going to be talking about log transformations. So a log transformation has the effect of compressing the values of the upper end of the scale. It can only be applied to positive values. It reduces all values, and values between 0 and 1 become negative. So let's complete the table below to see this in action. So we have all of these values here, and we want to log each of them. Let's come to our CAS calculator to see how we can do this most efficiently. So I've called a column value, and I've put in all the values here. I now want to come to the next column, and I'll call this log value. Then I'll come to the cell beneath it. I will hit equal, and that will allow me to define what this column is. I'll hit Control, log, and now I'm going to log this column here. Now you have to put what the base is going to be. Remember, in further maths, the base is always 10, and the calculator also assumes the base is 10 if you write nothing. So I'm going to write nothing there, and it will put in there automatically 10. So don't waste your time by typing in 10, just leave it blank. Then here, I want to go var for variables, and I want to put in value here. So I am logging the value here. Then I hit enter, and I get all of my values. Now, as you can see, some of them are approximate and some of them are exact. If you want them all to be approximate, what you're going to do is you're going to come home, you're going to go settings, you're going to go document settings, and instead of calculation mode being in auto, you can just go approximate and then go okay. Then we'll go back to our current, and now they're all in decimals. So they're all approximate now. So I can now come and just insert all this data into this, and we can just see what each of them looks like. So as you can see, if I can get this, my first one is negative 0.5. And that makes sense because we know that values between 0 and 1 become negative. So as you can see, this is 0.3, so it's between 0 and 1, and I get a negative out there. And now we're just going to continue on. The next one will be 0.3. So it'll be 0.3 here. Then we continue on. The next one is 30, and 30 became 1.475. So we'll call that 1.48. We'll do a bit of rounding. The next one's 32, so it's going to be 1.4, and then we'll round up to 1.4, 1.51. 1.51. The next one is 55. Now 55 was 1.74. 1.74. And then the last one, 120, was 2.08. 2.08. So we're just rounding to 2 decimals there. Okay, let's just take a step back now and appreciate what we're being told here. Note that it says that a log transformation has the effect of compressing the upper end. And this makes perfect sense because, as you can see, 120 got scaled back all the way down to 2. So it had a much bigger effect on the larger numbers than opposed to, like, for instance, 30 got scaled back to 1.48. So as you can see, the bigger the number, the bigger the scaling back occurred. And that's really going to help us out as we now talk about the effect of using a log transformation to linearize or to make more linear our data. So just take note, a log transformation has the effect of compressing the values of the upper end, the bigger values of our scale. All right, I'll see you in the next part.